So why study organic chemistry? Well, because organic chemistry is life, all right? And in anatomy, this next unit that we're getting ready to do after this is basically cell respiration. And with cell respiration, you guys probably know the equation, C6H12O6 plus 6O2 yields 6CO2 plus 6H2O plus energy, right? I mean, you've been taught that. I'm going to show you like how it happens. Okay, like we're going to go into, after Christmas, we'll go into like, what does all this mean? So we'll go into like the Krebs cycle, and we'll go into glycolysis and etc. I'll actually like show you the mechanism behind it, and show you how it's really kind of pretty the way it all works. Maybe you'll gain a little bit more respect for it. So, but before we do that, I have to show you a little bit of organic chemistry. Okay. So when you look at this equation, I'm going to guess that most of you understand that, oh, there's 6 carbon here, so there has to be 6 carbon over here, right? The balance equation type thing. We good with that? Yeah. Well, do you guys realize that there's 19 steps right here? Have you ever been taught that? No. Just to turn this into a usable form, all right, it takes 10 steps. Okay, it's called glycolysis. And if it doesn't have this, if it doesn't have enough oxygen to create this at the very end, this all gets backed up and it forms what's called lactic acid fermentation. I don't know if you've ever heard of that before or not, but in order for your body to keep going at a higher rate than what you can actually do, in other words, you're working out so hard that you can't get enough oxygen in, your muscles start to burn, right? You felt that before, right? What has happened is this process of adding oxygen to form carbon dioxide is going at a rate that's too fast. So this reaction actually will stop. And it literally is because there's not enough oxygen to receive electrons to form water and ATP at the very, very end. So if you want to look at this, glycolysis, Krebs cycle, electron transport chain. That's like the 3 main parts of cell respiration. If you've never been shown that before, okay? So again, it's like splitting the glucose is glycolysis. Forming the carbon dioxide is the Krebs cycle. And then reaping the benefit and creating water is the ETC, the electron transport chain. Okay? So that's why I show you this. All right, let's talk about carbon. I'm going to go through all the slides that I want to today, and then I'm actually going to give you like some physical notes, and you guys are actually going to practice doing this today. Okay, you're going to try to form some organic compounds and some structures. All right. We're all carbon-based life forms. We are based off carbon because of the way that its chemistry is set up. It has 4 valence electrons. Are you guys okay with valence electrons? Do I need to go over that? 4 outside electrons. So in other words, if you remember from chemistry days, you have inside and outside. It kind of goes like there's 2 on the very inside, and then you get to these magic number 8. Okay. And if you can fill up a shell orbit and have 8, it's a stable atom. Okay. Now, it doesn't mean that it's not charged either negatively or positively. It just means that it's filled to a capacity. Okay. Like the shell can either drop down or it can raise up to a higher level. So carbon, because of the way it's set up, it has 4 spots that it can bond. And this creates all kinds of arrangements for itself and for other elements like hydrogen especially. And that's what we're going to talk about. First off is this idea of just carbon and hydrogen bonds, and they're known as hydrocarbons. Okay, so that's the first organic chemistry that we'll talk about. And that's why like astrobiologists and astronomers, they get really super excited when they find hydrocarbons on some of these like moons and stuff in outer space. You know, like the Triton's got methane on it, or, you know, Titan's got some organic goo on it. They get really, really super excited because if you have hydrocarbons, you have the basic backbone for life. And if you have those, especially in water, you may end up getting more complicated versions of that, and then maybe eventually get cellular life. That's kind of the idea, okay? So with these hydrocarbons, you can have two different kinds. You can have what's called a saturated hydrocarbon, and you can have an unsaturated hydrocarbon. So for quiz questions for Friday, a quiz question might be, what are the two types of hydrocarbons? Saturated and unsaturated. Have you heard of saturated fats before? Yeah? How about unsaturated fats? Which is better for you, saturated or unsaturated? Yeah, do you know why? It all has to do with the fact that unsaturated fats have double bonds of carbons in them. That's it. And because they have a double bonded carbon in them, they're kinked up and they don't lay flat and smooth. So that means that there's more space in them when they're stacked on top of one another. So that means that at room temperature, they're typically liquids. Okay, like vegetable oil. You know, usually that's an unsaturated fat, and you get into like good oils like olive oils and fish oils. They're typically at room temperature liquids because they're unsaturated. And what does that mean? It literally means that it doesn't have a full capacity of hydrogens around all the carbons. If you are saturated, you are full, every single possible spot is full of hydrogens. And I'll draw some of those out here in just a little bit, okay? So instead of like counting and drawing all the Lewis structures, which you guys did in Chem 1, I'm going to show you some shortcuts, okay? We're not going to draw out all the different shells and all that. There's no need, okay? I'm going to show you some real quick shortcuts of how to deal with carbon. I will make you memorize 3 formulas. This one, and then shoot, the 2 that are down below as soon as the little thing goes away. The CnH2n and the CnH2n minus 2. You're going to have to memorize those 3. And it's pretty simple. If they're saturated, that means that there's no double or triple bonds. You use the CnH2n plus 2. The N represents the number of atoms, okay? So for example, if you had 1 carbon, you would put a 1 in for the N. So it'd be C. You can put the 1 if you want. I don't care. I'm not a chemistry teacher, like I said. So it'd be C1, and then you'd have H 2 times 1 plus 2. So that would be 4. Pretty simple, right? Okay. And it's much, much easier to do this than if I said, okay, how many hydrogens are there in a compound that has 12 carbons? Okay, draw them all out. That's going to take you about a minute, maybe 2 minutes to draw them out, whereas I can just say 26. Because 12 times 2 is 24 plus 2 is 26. Okay? And it's the same thing if you have double bonds or triple bonds. All right? If you have double bonds, then you use the CnH2n, and all you do is just multiply it. If you have 20 carbons, you have 40 hydrogens. If you have triple bonds, you just subtract 2. So if you had 10 carbons, it'd be 10 times 2 minus 2, so it'd be 18 hydrogens. We'll do some. I'll show you some examples of it. All right. you're going to have to memorize those 3 equations and then these 10 prefixes. Okay. I'm guessing you've heard of meth. And it's for methyl is what it's for, but meth just means 1 carbon. Eth means 2 carbons. Prop, it looks like prop, but it's prop, is 3. It looks like but it's bute, has 4. Pent, and then it gets really simple. I'm assuming you guys have heard of pent, hex, hept, oct, non, and dec. Yeah, those are all really, really common prefixes, and they're ones that typically you use in math class, like an octagon or a hexangle or something like that. I don't know if a hexangle would be something, but a pentangle. There we go. You got a 5-sided triangle or something. Sorry. Or like a decade, 10 years. All right, but meth, eth, prop, and bute, they aren't real common, so those are the 4 you may have to memorize. I every once in a while I have to stop and go, yeah, prop is 3. Yeah, and bute is 4. Okay, so those are the 10 that you'll have to know. All right, and then here's how you would name them. Okay, so again, if we're talking about alkanes only, alkane ends with A-N-E. That's like the suffix. And if you want to think of it as standing for single bonds, that works for me. So if you hear alkane, think of either single bonds or, if you understand this, fully saturated. It's a fully saturated hydrocarbon. So what you're going to have is a prefix, meth, eth, all the way to dec. And I mean, these things, I'm not having you do 11, 12, all the way to 20. I'm just doing 1 through 10. But you'll just throw on the prefix. Okay. So if you had 4 fully saturated hydrocarbons, it would be 4 is bute. And since it's fully saturated, it'd be ane. So it's butane. Maybe you've heard of butane lighters. Okay. Or if there was 3 of them, maybe you've heard of propane. Does anybody live in the country? Have a big white, those tanks outside your house, or like a propane, torch. Same thing. We heat our houses in the city. Usually it's a combination of ethane and methane. It's called natural gas. So a little combination of it. When you start getting down to octane, maybe you've heard that in gasoline. It has so much octane, it burns 87 octane or 90 octane. Those are all saturated hydrocarbons. Okay. Now, I'm going to stop this part and we're going to draw a few of these. So if you got like the back of a sheet or something, if you want to write some of these down. These are just alkanes. We're going to start simple. So that means that we're only talking about things that have single bonds between the carbons and all hydrogens are available. Okay. So they're all filled up with carbons. The simplest alkane, the only way you can draw it is this guy right here. Sometimes you'll see it just written like this. Okay. And that's methane. So we're not going to deal with methane because you can't draw a line structure with methane. It would just be a dot. So I'll just show you that. Now we're going to move on to a little bit more complicated. You're not going to see me draw out this because it takes way too long and it gets messy. Since there's 2 carbons, without cheating and looking, use the formula and tell me how many hydrogens there would be. 6, because 2 times 2 is 4 plus 2 is 6. Okay, so and if we want to look at our little chart that's hopefully you still have up there, What's the prefix for 2? You have 2, F, and they're all single ane. So if they're single bonds and there's 2 carbons, it's ethane. Does that make sense? Okay, so now we can work backwards, and let's say it's propane. Go through your checks. The ane tells you that they're all single bonds. The prop tells you what? There's 3, so it's C3. How do we get how many H's? 3 times 2 is 6, plus 2 is 8. Then we can draw them all out, but I'm not going to do that. Let me show you a simpler way. Every single line equals 2. So there's 1, 2, 3 carbons. Much easier, right? The line structure is much, much simpler than drawing out all the carbons. You're just assuming that all the H's, there's 3 H's here, there's 2 H's here, and there's 3 H's here. How do I know that? Because carbon has 4 bonding spots. If you want me to draw it out, it would look something like that. I would just rather draw the lines. But if you don't understand how I drew that like that, please let me know. So now let's do this one. 1, 2, 3, 4. And I count it in my head. I start off and I go 1, 2. Watch this for a second for me. 1, 2, 3, 4. C4, H10. How did I do that so quick? I just multiply it times 2 and add 2. So this is butane. So then let's do pentane. What's pent mean? C5H12. 1, 2, 3, 4, 5. Now I went right in order, right? 1, 2, 3, 4, 5. Now I'm going to give you some that aren't in order. Oh, can I like draw it? Okay, we'll do one more. Okay, watch this. 1. I'll do a different one. 1, 2, 3, 4, 5, 6. And get in the habit of doing this. 1, 2, 3, 4, 5. Get in the habit of numbering them, because I'm going to tell you something. That, watch what I do, is the same as that. Ooh, because this thing's in space and it can move around. And so when you guys start playing with the Molly mods that I have over here and the kits, you're going to be looking at it going, oh, wait, that bond is here. And you'll flip it around and you'll go, oh, it should be called, when we start naming these, there's going to be like things like 2-methyl pentane, and as opposed to like 4, in math class how you always reduce fractions and stuff. Yeah, it's the same thing with chemistry. You always use the smallest numbers possible. You always try to reduce it. So, and I'll explain that when we get to that later. All right, so you guys try this one. What's this going to be? Well, let me add that. What's the chemical formula for this guy? And what would the name be? Octane. Very good. Questions? Okay. I think the best thing for you to do is just practice a few. If I give whatever I give you, you give me the other 2, the name and the drawing or whatever. Okay. So, and I'm going to leave that blank, so you actually have to figure out what the H's are. So this would be the formula, the name, and then the line structure. Draw it out. How about that? And then I'm going to use a different sheet. That way it doesn't bleed through. All right, give those 4 a try. Okay, so let's take a look at these. Okay, so this one shouldn't have been that hard. Just figure out that the formula is going to be 12. And then the name on this is going to be pentane. And then your line structure is 1, 2, 3, 4, 5. Heptane is going to be 7. So that's going to be 16. And that's 1, 2, 3, 4, 5, 6, 7. And then count them 1, 2, 3, 4, 5, 6, 7, 8. C8. Ooh, how about an 8? H18. And that's going to be octane. Now, on this one, you got to do a little like reverse. If you want to do the whole 2n plus 2 equals 8. If you want to do that, that's fine. Here's an easier way. Okay. If you just think about it, I know it can't be 4. Okay. So just go 1 less. So split it and then move 1 number down. So it's 3. If it was 20, all right, if it was like H20, you know it's not going to be 10, it's going to be 9. Do you see my reasoning behind that? Okay, good. All right, so in this case, this is going to be, 3 is going to be propane, and it's going to be that. Everybody good? Don't let me lose you, because this is baby steps. This is literally the beginning of this stuff. Very good. Okay, so let's keep going since you guys got this. This is awesome. All right, so now let's pretend that we are going to replace one of the hydrogens with something else. And in this case, that something else is going to be a carbon. Okay, It could be an oxygen, it could be a chlorine or an iodine or fluorine. It could be any basic non-metal. You guys know the difference between ionic and covalent compounds, right? Okay, so we're talking about anything that could covalently bond to a chain of carbons, all right? Because that's basically all this is a bunch of carbons linked together. Either, in this case, since we're talking about alkanes, they're all linked together in single bonds, all right? So what you'll do is find the longest chain and name it. So here's the puzzle part that comes in. Here's the Sudoku or whatever. You look at and try to figure out where the longest is, write that down, and then whatever's branching off of it is going to be numbered and named accordingly alphabetically. Okay? So there's some simple rules to this. And let me show you. So for example, let's say I had a structure that looked like that. In order to figure out what this is, an easy thing to do is if you've got a highlighter or something like that is just, and this one doesn't really matter because if I go this way or that way, it's still 3, right? 1, 2, 3 is the longest. So the longest chain is going to be prop. And then are they all single bonds? Yes. So it's ane. But then I've got this thing that's sticking off here. That is a single carbon. What is the prefix for one carbon? So this is methyl. This is methylpropane. Okay. Now, I don't have to put the 2 on there because that's on the second one. You guys, you smart kids, tell me I could put the 2 like that. Why do I not have to put the 2 there? Can I have something like that and say that this is the longest chain, or and say that, oops, crap, I did that wrong. Pretend that I didn't do that. That this is the longest chain? Nope, I can't, because if I add a methyl group to the end, I just added another carbon. So I created, instead of propane, I created butane. Does that make sense? So in order to get a functional, it's called a functional group. Functional groups replace. I'm replacing a hydrogen with something. In this case, it's a carbon. And it's what's called an alkyl group. Alkyl groups are just alkanes that hang off of a bigger alkane. All right? Like this. All right. So here's where I told you that you should start numbering these things. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of these critters. I think that is the longest chain. Because if I went like this and went 1, 2, 3, 4, that's not right. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So that's my longest chain. So I know that my base name is going to be non-ane, and off of the 4th and the 5th, I've got these methyl groups. Okay, because they're just, that's a methyl. There's one carbon right there. So this is going to be on the 4th and on the 5th. Oops, how about a 5? On the 5th, I'm going to have a methyl. So it's called 4,5-methyl nonane. Yes.
Okay, so like on
then it'd be, nope, not yet. Oh, if it was like this, yes, it'd be ethyl. You're getting it. And that's what I was going to do next. So, but what I want you to be careful of is watch this. Go ahead and name that for me, somebody.
Methyl octane.
What? Where is it at, though?
Oh, 6 methyl. Yeah. Or 2.
How about now?
Well, it's just really.
Yeah, I know. That's why you have to number these both ways, and it has to be the shortest or smallest numbers, because it's in reality it's 1, 2, 3. This would be 3 methyl, 1, 2, 3, 4, 5, 6, 7, 8 octane. Okay. If you had, Spence, you okay? Okay. If you had multiples of these, let's say we did this and then this, okay, you just got to add them up and see which way's the smallest. Because if I went this way and I went 1, 2, 3, there's one on 3, 4, and 6. But if I go this way, it's 1, 2, 3, 4, 5, and 6. Does that make sense? That's going that direction. That's going that direction. So I want to go this way because it's less numbers. Okay. Just always use the direction that gives you the smallest amount. All right. Okay. So let's say we had something like that. All right. So let's see. If I go this way, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it doesn't really matter. We're going to say that this is my longest. Okay. And we're going to say that they're all single bonds. So it's hexane. And off of the 1 to the third one, I've got 1, 2. So it's ethyl. If I have an alkane hanging off another alkane, it's called an alkyl. So it ends in YL. Alkyls are alkanes that are acted as functional groups or replacements for the hydrogens. Okay? So I can go through this and let's have you guys do a name here. 2, 3, 4. Methyl. And I haven't even put on the dyes and tris and stuff like that. I'm just waiting. You probably should be putting those on there. Octane. Draw that. 2, 3, 4 methyl octane. And you can type it into Chemistry Builder or PubChem, and it'll do it for you. But if you don't want to do that, so here's the 2D structure of it. You'll notice that it says, I didn't want to throw too much at you today because you're like, Stubbs, you just made us remember meth, eth, and all this stuff. That's for carbons. When it's functional groups, you use di, tri, tetra. Yeah, I know. You got to love it. That's why I didn't want to do too much today with that. But so, yeah. So in actuality, I should have a tri right here Oops. Like that. And just go 1, 2, 3, 4, 5, 6, 7, 8. And then number them 1, 3, and 4. I think that's good enough for today. Yes, it'd be a try because there's 3 methyls. That's a methyl, that's a methyl, and that's a methyl. If it was like that, then this would be 2, 3 dimethyl 4 ethyl octane. When you woke up this morning, did you think you would see 2, 3 dimethyl 4 ethyl octane and maybe kind of understand it? It is. Yeah, it is. It is a mouthful. What is that? It's a hydrocarbon. What does it do? I have no clue. Who knows? My guess is it's probably flammable, like most of these things are, but I don't know. And to be honest with you, I'm not going to go into like the properties of these that much. I just want you to, like, when my professor started doing this to me in college, I was like, oh my gosh, I don't get this. This is just too much because I was never shown like the basics. So if I can just show you the basics, then when he starts throwing out things, that look like this, and you got to, something like that, you're not going, what? And you can just say, oh, that's an alcohol. That's a benzo. It's a benzo ring with an alcohol attached to it. You'll be able to pull out the functional groups like that. So, which you need to know for AP Bio, apparently. So, yeah.
You are? I think so. I'm not.